Hello everyone. Today we are gonna introduce about Nitrogen-Vancancy-Center. Let's get started. Have you ever heard about Nitrogen-Vancancy-Center? Nitrogen vacancy is a kind of material that nitrogen is added into the carbon crystal structure as a point defect. It is similar with the case of N-type semiconductor that 15 period elements are added into the silicon crystal as an impurity. Because nitrogen has a one more valence electron rather than carbon, they cannot make 4 bonds and have a lone electron pair. Thus, in the vacant position, there are 5 electrons which are come from adjacent carbons and lone pair. In this case, we call this vacancy as NV0, and if there is one more electron which came from another atom, it's gonna be NV-. This is the energy diagram of nitrogen vacancy center. There are 3 electron energy levels: ground, excited, and metastable states. The spin of ground and excited states are triplet, and the metastable state is singlet. The electron transition from ground to excited state is caused by ZPL of 638 nanometer. Some portion of photons are released as a ZPL, and all the rest is luminescences which are occurred in 640 to 800 nanometer range. It is called as vibrational sideband. In this path, electrons in the triplet move to the ground state via metastable state and then emit the energy. So there are 2 pathways. The lifespan of radiation from excited state is about 30 nanoseconds, and in the case of metastable radiation, it is about 250 nanoseconds. In the triplet system, 2 states which have ms plus and minus 1 are degenerated. Also, the energy level of ms0 is more stable. The energy gap between these 2 states is called zero field splitting. If we make external magnetic field, the energy gap between ms plus 1 and minus 1 gets splitted. And the magnitude of formula is like this. From now on, we are going to introduce a relation between NV and qubit which have a quantum mechanical concept. In quantum computing, a qubit is the basic unit of a quantum information. Ordinary bit physically realized with a 2-state device. On the other hand, quantum unit qubit has a 2 states simultaneously, so we can use this concept as a bit in real computer. Because of its size is a quantum size, so we can concentrate the information process and operation in effective size. Look this energy diagram. Electron in excited state has 2 pathways to go ground state. One is radiation transition, and the other is passing vibrational sideband. As we mentioned, there is a significant time gap between these 2 pathways. Therefore, if we can detect the time difference sensitively, we can calculate which paths the electron passed by. Before we detect the time, we can't find which paths the electron passed by. We can think this system as a qubit which has 0 and 1 simultaneously. Each pathway's possibility can be controlled by the magnitude of magnetic field. Next, let's talk about manipulating the qubit by magnetic field. As we applied magnetic field stronger, the split between ms-1 and +1 gets further. Assume that the ms-1 levels get stable. Electrons tends to fill in low level. If the magnitude of magnetic field is strong enough, the gap between ms0 and -1 gets narrower and becomes almost 0. Since in the case of ms0, the tendency of moving to metastable state is weak, and ms plus 1 and minus 1 causes tendency are strong. So, if the magnetic field gets strong, it would be easy to get excited state to metastable state transition. It means that if we enhance the magnetic field, the number of electrons which is passing by the metastable state gets larger. Now, we understand the way to control the probability of each pass. EPR is critical evidence of controlling probability of NV qubit. As you can see in this graph, if we enhance the magnetic field, frequency of ZPL decrease. It means that energy level is splitted. So the gap between ground state and excited state is slightly decreased. Also, we can check the existence of two peaks which indicate the different energy level by splitting. Finally, NV center can be used in various equipment. Following are some of them. First is single photon donor. One NV unit absorbs one photon energy to excite electron to excited state. Because of large coupling to side bands, the transition can be pumped via green light. After that, electron will emit a specific wavelength photon which is red color. Therefore, nano-size NV can be used as a single photon donor. Also, we can measure ion concentration sensitively with parametric ion and NVC. If there are parametric ion near NVC, the electron spin relaxation speed increases significantly. Therefore, by measuring this difference, we can measure parametric ion concentration. Besides single spin NMR, fluorescence biomarker, strain rate, and pressure sensor are examples of NV's application. This is end of our video. Thank you for watching.